Newton's method, it's a trick to find a zero. The goal is to find this value. What we do, we pick a point. Let's call this x sub 0. We run up to the function and we say if y equal f of x, then this is x sub 0 f of x sub 0. And if we find the slope of the tangent and draw the tangent line completely, we would say the equation for this line is y minus y1 equal, isn't the slope of the line f of x sub naught, the slope of that line, into x minus x naught, right? And I could say that at this point right there, if I call this point x1, wouldn't y be 0 for that green line? So wouldn't 0 equal wouldn't 0 minus f of x sub 0 equal f prime of x sub 0 into x sub 1 minus x sub 0? And now if I solve this problem for x sub 1, divide both sides by f of prime of x sub 0, and say x sub 1 equals, move this to the left, x sub 0 minus f of x sub 0 over f prime of x sub 0. Now, I'm going to shrink this just a bit. If I take x sub 1 and I run up to the function, that point is x sub 1 f of x sub 1. If I draw a tangent, there's a tangent. The equation for that new line is y minus y1 equals m, which is f prime of x sub 1 into x minus x sub 1. And if I run down straight to that point, I call this x sub 2, y would be 0. I could say 0 minus f of x sub 1 equal f prime of x sub 1 into, and this x is actually x sub 2. And if I solve for this x sub 2, again I divide both sides by f prime of x sub 1 and move this over, I'll get x sub 2 to equal x sub 1 minus f of x sub 1 over f prime of x sub 1. Now, what's the deal? The deal is this 0 was really far from what I want. This 0 is closer. This is even closer. If I repeat that one more time, do you see that this 0 will be closer? So if I look at the trend, I choose, that's the key point of this method. I choose x sub 0, the initial point. This says x sub 1 is x sub 0 minus f of x sub 0 divided by f prime of x sub 0. X sub 2 was x sub 1 minus f of x sub 1 over f prime of x sub 1. If I want to find any x, take the previous x minus f evaluated at that divided by f prime. And if you remember, and that's the famous Newton's method. And if you remember, if I choose my first coordinate, then x sub n plus 1 will be answer minus, right? Let me put that here. X sub n plus 1 will be my answer once I choose that, minus f of the answer divided, oh, that doesn't sound right, but you know what I mean. And that's really the trick. On page 276, I have a problem. It says using Newton's method. Here they're choosing x sub 1. I graph this for you. This is addition. This is me giving you an extra graph. The 0 is right there. They chose -1. There's a catch to this method. I'll tell you what that is after I'm done with this problem. So this is my f. what I need to use this formula, I need f, I need the derivative, and the initial choice. So, if I want to find x sub n plus 1, let me go back to x sub n plus 1. That is x sub n minus f of x sub n. And I suggest you write it on every problem so that you remember what it is. Divided by f prime of x sub n. So, if I really look at this, this is very close to what we did back in the days with limits when I used my calculator. I'm going to show you how to use a calculator again. So, to find x sub n plus 1, that would be x sub n, not a problem, minus f of x sub n, that is 2 into x sub n cubed, minus 3 times x sub n squared plus 2, divided, what would be the derivative of this? The derivative of this will be 6x squared minus 6x, if I'm not mistaken. So that's 6 into x sub n squared minus 6 into x sub n. So, when you say let the first choice be negative 1, so x sub 2 is negative 1 minus plus, I'm sorry, minus, right, minus twice negative 1 cubed minus 3 times negative 1 squared plus 2, 6 into negative 1 squared minus 6 times negative 1. And if I get my calculator out and input this stuff in, and here it is, a bit higher. Okay, if I take negative 1 minus parentheses 2 times a negative 1 cubed minus 3 times a negative 1 plus 2 divided by 6 times a negative 1 squared minus 6 times a negative 1. I'll get negative 1.25. Okay, I found a mistake. I went back. I noticed I didn't square this. There, now better. Okay, I'm getting negative 0.75. So, this is negative 0.75. Now, do you agree that x sub 3 is going to be negative 0.75 minus 2 times negative 0.75 cubed minus 3 times negative 0.75 squared plus 2 divided by 6 into negative 0.75 squared minus 6 times negative 0.75, and let me plug that in and see how that works. And if I go in and say let's take negative 0.75 minus parentheses twice negative 0.75, oops, not squared, cubed, minus 3 times negative 0.75 squared plus 2 divided by 6 times negative 0.75 squared minus 6 times negative 0.75, and if I throw that in, I'm looking at a negative 0.68, negative 0.6825, negative 0.6825. Well, let me show you how I'm going to do this slightly different. Instead of doing what I did, I'm going to say let x1 equal negative 1. There's the calculator. Negative 1, negative 1, enter. Got it. Now I'm going to say x sub 2 is going to equal answer minus twice answer cubed minus 3 times answer squared plus 2 divided by 6 into answer squared minus 6 times answer. So, and if I get my calculator, now I know you're thinking, why is he doing that? Well, you should know by now. If I take my answer minus parentheses twice, if I put the answer in and cube it, minus 3 times the answer, square it, plus 2 close parentheses divided by 6 times my answer squared minus 6 times the answer. I'll get the negative 0.75. To get x sub 3, guess what? Do you know what's going to happen now? I'm going to go up and evaluate. And what am I going to get? A 0 point. Actually, let me copy that. And now I could do not this, I could do the entire section in no time. That is, if I want to find x sub 4, instead of plugging in negative 0.6825 to 6 decimal places, all what I have to do is go on my calculator now, hit back up, evaluate. Okay, it's not working. Give me a sec. Back. Something stuck. Let me. Okay. Now if I go back up with this answer and evaluate it, that's my next answer. And this is what I got. So it's getting more accurate. Well, what they wanted us to get it accurate to 4 decimal places. So this is accurate to 1 decimal place. If I do it again, and I did, that's what I got. So you know how to do that by now, right? And you notice this is accurate to 4 decimal places. So I'll say this x right here is roughly negative 0.6776.